Hello everyone, welcome to my channel. I'm Komal Shekhawat and I hope you all are doing well. In this video, I'm going to discuss the topic dummy variables. Okay, so let's get started. So first of all, what are dummy variables? See, dummy variables are those variables which are created to study the characteristics or attributes that have no numerical data on them except for the information on the presence and absence of the quality. So if the dummy variable is present in the regression model, a dummy value of 1 is assigned, otherwise 0. Okay. So we are going to discuss this concept of dummy variables under three cases. So first one is there is only one dummy variable in the regression model with two categories. For example, the dummy variable that has been introduced in the regression model is gender with two categories, male and female for instance. Okay. You can also suppose dealing with a dummy variable, for example, residence. So it is having two categories, rural and urban, right? So such kind of attributes are converted into numerical data to regress or to estimate the regression model by defining a dummy variable as follows. For example, the dummy variable, as you can see, is represented by di. So di equal to 0 for the base category, right? So suppose in this particular case, male has been considered as the base category and di equal to 1 for the other category, female in this case, right? So this is how you have defined a dummy variable with only two categories, di equal to 0 for male and di equal to 1 for female, right? Now under this first category, that is only one dummy variable with two categories, we can further have three different cases. Let's have a look. So the first case is regression model with dummy variable which is only one and no quantitative variable, right? So we are dealing with only one dummy variable with two categories, and such kind of regression models are called ANOVA model. Okay, now let's take an example. Suppose we are dealing with the population regression function which can be written as yi is equal to beta 1 plus beta 2 di plus ui, where yi is the dependent variable, betas are the regression coefficients, ui is the random error term, and di here is the dummy variable. So as you can see, in this regression model, there is only one dummy variable and there is no quantitative variable. Okay. Now, the non-stochastic PRF would be the expected value of this y for given di can be written as beta 1 plus beta 2 di. Okay, so this is our regression model. Now, how can we estimate the values for this regression model? So, to estimate the values, we write it as the expected value of y for given di equal to 0. So 0 was assigned for the category male. Okay, so if this di is 0, the value would be beta 1, right? So the expected value of y for given di equal to 0 would be equal to beta 1. Similarly, the expected value of y for given di equal to 1, so 1 was assigned for female, so if the value of di is 1, the expected value of y for given dummy equal to 1 would be beta 1 plus beta 2. Okay, now here the regression coefficient beta 1 measures the mean value. Okay, it measures the mean value of variable y for the base category, which is the male, and beta 2 is called the differential intercept coefficient. The differential intercept coefficient tells us by how much does the expected value of y differ across the categories. Okay. Now the next is ANCOVA model. That is, we are dealing with the regression model with one dummy variable and one quantitative variable, and there is no interaction between the dummy variable and the quantitative variable. Okay, so let's take an example here. Y is a dependent variable which is consumption. X that has been introduced in the model is an independent variable which is a quantitative variable and it is representing income. And one dummy variable D for gender has also been introduced. So D equal to 0 for male and D equal to 1 for female. So in this case, the ANCOVA model or the regression equation for this ANCOVA model can be written as expected value of y for given di is equal to beta 1 plus beta 2 di plus beta 3 xi. Okay, so here you can see there are three regression coefficients. Okay, one is the intercept and other two are the slope coefficients, one for the dummy variable and other one for the quantitative variable income. Okay, now how can we find out the values for the dummy variables? So the expected value of y for given di equal to 0, that is for male, would be beta 1 plus beta 3 xi. So if you put 0 over here, this would be equal to beta 1 plus beta 3 xi. Similarly, the expected value of y for given di equal to 1 would be equal to beta 1 plus beta 2 plus beta 3 xi. Okay. Now here in this case of ANCOVA model, the value beta 1 again measures the mean value of y for the base category. Okay, and beta 2 here represents the differential intercept coefficients. That is, it tells us by how much the expected value of y differ across the categories. That is, how much it differs across male and female. Okay, now the third case under this category is ANCOVA models. So the first case was there is only one dummy variable. Second was there is a dummy variable and a quantitative variable but without any interaction. The third case is there is a dummy variable with two categories and a quantitative variable, but there is an interaction between dummy variable and the quantitative variable. So such kind of models are called ANCOVA models. Okay. So this is the case of ANCOVA models with interaction between dummy and quantitative. The previous one was the ANCOVA model without interaction between dummy and quantitative variable. So in such cases, the regression equation would be expected value of y for given di is equal to beta 1 plus beta 2 di plus beta 3 xi. So this is same as the previous equation without interaction, but in this case, when there is an interaction between dummy and the quantitative variable, you need to include another category, that is beta 4 di into xi. Okay. Now, how do we find out the values? So, for the expected value of y for given di equal to 0, that is for the male category, the value would be beta 1 plus beta 3 xi because di is 0. So, if you put di equal to 0, the equation would be beta 1 plus beta 3 xi. Okay. Now, next is the expected value of y for given di equal to 1. So, this would be beta 1 plus beta 2 plus beta 3 xi plus beta 4 xi, which we can further write as beta 1 plus beta 2 plus beta 3 plus beta 4 xi, right? Now, in this equation, you can see over here beta 2 has been added, right, as compared to the previous equations. So beta 2 here represents the additive dummy, okay, and here beta 4 represents the multiplicative dummy, okay. Now what is an additive dummy and multiplicative dummy? The coefficient of the additive dummy beta 2 helps us to see if the difference in the intercept across categories are statistically significant. Okay, and the coefficients of the multiplicative dummy, that is beta 4, it tells us about the statistically significant difference between the slopes. Okay, So the beta 2 additive dummy tells you the difference, statistical difference in intercept, whereas the multiplicative dummy beta 4 tells us the statistical difference between the slopes. Okay. Now, the next case is if there is more than one dummy variable and each dummy variable has two categories. So the first case was there is only one dummy variable, each with two categories, and now we are dealing with the case of there is more than one dummy variable and each dummy variable has two categories. Okay, so under this category again we are going to deal with three models: ANOVA model, ANCOVA model without interaction, and ANCOVA model with interaction. So first let's have a look at ANOVA model. Okay, now suppose we have more than one dummy variable. One is gender and the other one is marital status. So we have introduced two dummy variables in our regression model. Okay, so the first dummy variable is gender. Okay, so we are denoting this dummy variable as D2. So here this dummy variable gender has two categories: D2 equal to 0 for male and D2 equal to 1 for female. Okay, the second dummy variable that has been introduced is marital status, and this dummy variable is denoted as D3. Okay, so D3 equal to 0 for married and D3 equal to 1 for unmarried. Alright, so this is how you assign dummy values for dummy variables. Okay, now the regression equation in this case can be written as expected value of yi is equal to beta 1 plus beta 2 d2i plus beta 3 d3i. Okay, so there are three regression coefficients: beta 1, beta 2 and beta 3, and two dummy variables d2 and d3. Okay, and there is no quantitative variable because it is ANOVA model. Right, now for this particular ANOVA model, the regression equations would be as follows for different values of dummy variable. Okay, now let's have a look how we can write down the equation for this dummy variable or for this regression model. So the first one would be expected value of yi for given d2 equal to 0 and d3 equal to 0. It means this is the value for male category and married, because d2 and d3 both are 0. It means we are dealing with male and married. Okay, so if you put d2 and d3 equal to 0, the expected value of yi would be equal to beta 1, right? Similarly, for the expected value of yi for given d2 equal to 0 and d3 equal to 1, that is male but unmarried, right? So if you put d2 equal to 0 and d3 equal to 1, this would be equal to beta 1 plus beta 3. Okay, next is the expected value of yi for given d2 equal to 1 and d3 equal to 0. That is, we are dealing with female and married. Okay, so married females. So the expected value of yi for married females would be equal to beta 1 plus beta 2. And the last equation would be expected value of yi for d2 equal to 1 and d3 equal to 1, that is female but unmarried. So the expected value of yi for unmarried females would be beta 1 plus beta 2 plus beta 3. Okay, so I hope you are getting this point, that how you are going to write down the regression equations and the values for ANCOVA model and ANOVA models under different dummy variable categories. Okay, so we have done with ANOVA model. The next would be ANCOVA model, where there is no interaction between dummy value and quantitative variable. Okay, so in this case, the regression equation is written as the expected value of yi is equal to beta 1 plus beta 2 d2i plus beta 3 d3i plus beta 4 xi. So this is the same as previous equation. we are adding over here only another regression coefficient and a quantitative variable x. Okay, so there are total 4 regression coefficients, one intercept, 2 dummy variables, and one quantitative variable x. Now, in this case of ANCOVA model, how we are going to write down the 4 different regression equations. So again, the same process is being followed. So the expected value of yi for given d2 equal to 0 and d3 equal to 0. Okay, so this would be again male and unmarried. Okay, so if you put d2 and d3 here, 0, the expected value of yi would be beta 1 plus beta 4 xi. Okay, the next is the expected value of yi for unmarried males would be beta 1 plus beta 3 plus beta 4 xi. The next is the expected value of yi for married females would be beta 1 plus beta 2 plus beta 4 xi. And lastly, the expected value of yi is for married females would be beta 1 plus beta 2 plus beta 3 plus beta 4 xi. So these are the 4 regression equations in case of ANCOVA model without interaction between dummy and quantitative variable. Okay, the last case is the ANCOVA models with interaction between dummy variable and quantitative variable. Okay, so in this category, we are going to deal with two interactions. Please keep this in note that we are going to deal with two interactions when we are dealing with more than one dummy variable. When we were dealing with one dummy variable, there was only one interaction, that is between dummy variable and the quantitative variable. But when you are dealing with more than one dummy variable, there will be two interactions. So first interaction is the interaction of dummies with quantitative variable, that is d2i xi plus d3i xi. Okay, and the second interaction is that is called interactive dummy, because you are going to interact the dummies also. So both the dummies, if there are two dummy variables, so there would be an interactive dummy for d2i and d3i. Okay, now the regression equation in this case of ANCOVA model with interaction between dummy and quantitative would be written as expected value of yi is equal to beta 1 plus beta 2 d2i plus beta 3 d3i plus beta 4 xi. So this much equation is same as the previous one. Now you are adding over here three new components. So next is beta 5 d2i plus d3i. This represents your interactive dummy. Okay. Then beta 6 d2i xi. So this is the interaction of first dummy variable with the quantitative variable plus beta 7. So this represents your interaction of second dummy variable with the quantitative variable. So this would be your regression equation in this case. Okay. Now, since we have studied two cases, the last case is when you are dealing with a dummy variable and the dummy variable has more than two categories. By now, we have discussed only a dummy variable with only two categories. For example, gender, male or female, okay, area of residence, rural or urban, right? So there are only two categories for each dummy variable. What if the categories are more than two? Okay, so in that case, how you are going to define the dummy variables? So in that case, we define the dummy variables by taking one of the categories as the benchmark. Okay, so let's take an example. We have a regression model with a dependent variable y. So the expected value of yi would be beta 1 plus beta 2 d2i plus beta 3 d3i plus beta 4 d4i. You can see over here there are three dummy variables d2, d3 and d4. Three dummy variables are introduced in the model. Now have a look here. D2I equal to 1 for quarter 2. So suppose we are dealing with the expenditures or revenues or profits incurred in a particular year. So we are dealing with revenues earned or incurred in a particular quarter. Okay, so there are total 4 quarters in a year: quarter 1, quarter 2, quarter 3, and quarter 4. Okay, so we have a dummy variable expected revenue in 4 quarters in a year. So we have a dummy variable expected revenue or revenues for 4 quarters. So here we have a dummy variable with 4 categories: quarter 1, 2, 3, and 4. Okay, so it has more than 2 categories. Now how we are going to define the dummy values for this particular dummy variables? So have a look. D2I equal to 1 for quarter 2 and 0 otherwise. This means that we have assigned a value 1 for the quarter 2 and otherwise it is 0. So it is 0 for quarter 1, 3 and 4. Okay. Next is D3I equal to 1 for quarter 3. So we have assigned a value 1 for quarter 3 and otherwise it is 0. So it is 0 for quarter 1, 2 and 4. The next is D4I equal to 1 for quarter 4, otherwise 0. So this means that quarter 4 has a dummy value 1 and the rest of the quarters value is 0, right? So we have defined dummy value for 3 quarters: quarter 2, quarter 3 and quarter 4. Okay, so D2I, D3I and D4I are 0, then quarter 1 has value 1. Okay, so see, please make a note of this thing that if you are dealing with 3 categories of a dummy variable, then you need to introduce only 2 dummy variables because third would be automatically indicated, right? So here you can see we are dealing with a dummy variable with 4 categories. So you need to introduce only 3 dummies. As you can see, there are 4 categories: quarter 1, 2, 3 and 4, but we have introduced only 3 dummies: D2, D3 and D4. So there are only 3 dummies in this regression model, but this dummy variable has 4 categories because as you can see over here, D2, D3, D4, if these 3 are 0, then automatically quarter 1 exists. Okay, value 1 for quarter 1 indicates that D2, D3 and D4, these 3 are 0, right? Now how we can find out the values for this given regression model? So suppose we have a regression model wherein the expected value of yi is equal to beta 1 plus beta 2 d2i plus beta 3 d3i plus beta 4 d4i. Okay, so we have a dummy variable with 4 categories and we have introduced 3 dummies over here. So suppose we are dealing with the expected revenue incurred in 4 quarters in a particular financial year, right? So the expected revenue for quarter 1 would be D2, D3 and D4. These 3 are 0 and quarter 1 is 1, right? So the expected revenue for quarter 1 would be beta 1, okay? So suppose we are dealing with a regression model and we are regressing wages on area of residence. So there is a dependent variable y which denotes wages and there is a dummy variable which denotes area of residence. So there is a dependent variable, a dummy variable and there is no quantitative variable in the model. Okay, and this dummy variable area of residence has only 2 categories: di equal to 0 for urban and di equal to 1 for rural. Okay, now the question is find out the mean wages in rural and urban area. Okay, now to find out the mean wages in urban area, so that would be expected value of yi for given di equal to 0 because 0 here indicates urban area. Okay, so if you put di equal to 0, the expected wages expected wages would be yi equal to 2500, right? Similarly, the expected wages in rural area would be given by expected value of yi for given di equal to 1. So if you put di equal to 1, this would be 2150, okay, 2150. So here, this is how you can estimate the mean wages in rural and urban areas in a simple regression model, right? So I hope you have understood the concept of how you can introduce dummy variables when there is only one dummy variable with two categories, two dummy variables with two categories each, and when we are dealing with a dummy variable more than two categories. Okay, so I hope you liked the video. Thanks for watching. Have a good day.